Hi, this is a development update for MicroSplat 1.7, which I will be submitting to the asset store tonight. Given the current review timelines, it probably means it'll be out this week. So I've got a bunch of fixes in here and some new features, and so I want to talk about those. So let's talk about the fixes first. I discovered a bug in the EXR saving that Unity does, or it could be in the loading. Either way, basically what would happen is when I save out the terrain descriptor, which the object blending module uses, it would gamma correct the data, which would of course warp it, even though it wasn't supposed to gamma correct it. And that would produce a small line that you would sometimes see along the border of objects that were being blended. So I managed to counteract that bug, and now it's pretty much seamless. You'll occasionally get little spots where you can kind of see where a line happens, but you'll notice here it's pretty good now. Like if I really zoom in, I can see a little bit of an edge right here, which is unfortunate. But before that was sort of the norm. Now, in a lot of places, you really can't tell at all. It's very, very faint. So I'm going to continue working on that and see if I can get it absolutely perfect. But yeah, it's a little hard to figure out what gamma curve exactly they're applying. And it may also be something to do with one of the other lighting terms not being interpolated correctly. But it is a whole lot better than it was in the last update. So yeah, it's getting pretty close to perfect now, which is pretty awesome. So other stuff. Let me just consult my notes here. There was a bug in the texture cluster module that would cause the normal blending to be incorrect. That's been fixed. And then there was a mistake in the global puddle parameters, which has also been fixed. Now we can talk about new features. There were some other bugs fixed too, but more minor, documentation updated, all that kind of stuff. So let's talk about the new features. The first one I'm going to talk about is in the wind and glitter module. This is a really simple thing. Somebody had asked if they could, when glitter specular is on, which produces a really sort of wide specular sheen. This is kind of the wrong environment to use this, but we'll turn it on anyway. And let me go set this up. Strength. So what we have now is, instead of just having a straight up strength like we had before, we actually have a distance begin fade, the opacity at the begin fade point, and then a fade range end and the opacity there. So you'll notice these are 1, 1 here, so that's going to be like it was before, where essentially it's going to be full opacity all the time. And if I were to, and let me actually just switch to environment that this will be a bit better for, because it'll be already set up for it. We're going to go to the wind and glitter environment here. Here we are. All right, so here we have our wind and glitter going. We have a big wide specular in the glitter here. And now if we go to our glitter settings here, if I turn this down at the fade range, which is 150, you'll see that I turn this down in the distance, but when I'm up close, it's still close on the terrain. And so you can use this to basically start, maybe I want to start at 50 meters out, have it still be nice and hot, but have it fade in the distance. Or maybe I only want it in the distance. You can set this up however you would like. And that's a pretty cool little extension there. So let me just put this back. What was that? Threshold, fade 1, opacity at end 1. There we go. Now let's go back to our demo scene. All right, the next thing I'm going to talk about, let me just get a good shot here, is a new feature on the anti-tile module. So anti-tile module is very popular, which was pleasantly surprising to me, because Seems everybody realizes how bad tiling is on terrains, and that's great. So this was actually sparked, the idea for this in a rather unusual way. So OS X devices have a maximum of 16 texture samplers. What this means is that you can have 16 textures or texture arrays at once. Unity Lighting can take up several of those. So what happens on Macs is that you often run out of them. On PCs you don't, because you have 32 available, and you can also share them, and I've written all the code for sharing. So on PCs you can actually turn on everything, turn on every texture, and you'll still be under the limit. Now the interesting thing is that the hardware on a Mac fully supports this. The drivers that Apple provides do not. So there's no reason why they couldn't support this, but they just don't. One of my users was carefully balancing which effects he would turn on, and was like, hey, is there any way you could combine any more of these or somehow limit them? And I kind of had this idea for a while that rather than having individual detail noise features, distance noise, and the noise normal, of which you can select up to 3, just pack it all into one array and give every texture its own noise normal, its own distance noise, and its own detail noise. And so the way this works is that you now have this feature here called the anti-tile array features. And you can turn them all on, or you can turn individual ones on. So I could just have noise normal, detail noise, or distance noise, or all 3. And then what you get is, if you go to the texture array config here, right here, I've turned this on here. So if I turn this off, you'll see here's my normal array where I have 5 textures set up on this terrain. If I turn this on, you'll see that it adds slots here for a noise normal, a detail texture, and a distance texture for each one. And I can fill these out or not, with different textures for each one, right? For each terrain can have its own. So that's pretty cool. Now, one thing to point out is that the way that these are packed is in a very special way, so that if you do not provide the detail and distance noise textures, then the normal will actually come out in a higher quality. So if you're not using the detail and distance noise, or not planning to, go ahead and leave those blank, and you'll get a slightly higher quality normal. And if you are using them, for what this feature is, I don't think it's going to bother you that much. Now you do have all the normal controls over your texture arrays here, where you can set the size of them, compression, trilinear, anisotropic, etc. And then you can fill those out now for each array. And this will even work if you turn on texture clusters, for instance. I say I want 3 clusters. Now you have 3 clusters, plus you have your noise normal, your detail and distance texture. So we're not going to use clusters on this, though. So it's all just kind of works with everything, no matter what. So once you update this, it'll pack all those textures, and it'll produce this thing right here, this anti-tile array. This is another thing that I might not have shown in any of my diaries. Leonard, who does Vegetation Studio, he wrote up a little class. I took that and improved it a little bit, and it actually shows you what's in a texture array when you click on it. So basically, Unity never provided an editor for the texture array, so we just provided one. So anyway, this anti-tile array, you can see it's packed these noise normals and textures in for us. And now, if we go to our actual terrain and we go to our material, here's our material, we can turn on that feature. We can do anti-tile. Let's just turn on the noise normal, for instance. So this will recompile the shader. And now we have a shader recompiled. We have this new anti-tile section here, anti-tile array, and here's where you assign that array. So here's my anti-tile array, and I would just assign it here to get the anti-tile array assigned, just like I would with the albedo or normal arrays. And then I have basically properties for the scale of the normal, and this is shared across all the terrains. So this is that noise normal that we're using. Its overall global strength, which allows you to go really funky and if you make it too high. And then you can do the same thing for your detail scale and your distance scale. It looks like I forgot to hide these. I will fix that because it should only show these if I have these on, but it is showing all 3 now. So I will fix that before I release it. But if you had all three on, you would see you have your scale, fade, distance, and strength for the detail noise, and you have your scale, start of the fade, end of the fade, and the strength of the overall effect for the distance noise. And down here you have per texture properties for this. So if you want to actually adjust the strength of the anti-tile array normal in this case, you can do it for all three. If they were enabled, they would show up here. And so that way you can set this on a per texture basis as well. And so this is cool because it lets you have this effect customized for every texture in your array, which is great. Now there are some downsides. The other upside, of course, is that it's only using one texture sampler instead of 3 to 5. So that's a big thing for people on Macs. The downside, of course, is that you have more memory because you have an extra texture array with a texture for each terrain texture. And the other downside is that it takes quite a few more samples. If you have all three of these effects on, and you're using best blending mode, which is going to sample 4 textures for each pixel, or 4 texture sets, then this will add 12 samples because it has to sample for each of those terrain textures. It has to sample its unique normal, and then it has to sample the distance noise and the detail noise independently because they have different UV scales, right? Now, luckily, because they're in all-in-one array and you're often sampling the same texture, that actually can often be quite a bit faster than sampling separate textures. So it's not a huge performance cost, but it is more than the traditional independent techniques that are here before. But you don't have to share all this data. And then obviously there's more memory because you have more textures. So yeah, there's, I'm trying to think if there's anything else I should talk about here. Yeah, I think that's about it. So let me turn this back off. And what was the other thing I had to talk about? There was, oh, yes, so there is a new setting here, which you'll see this sampler mode. Okay, and this is in the core module. It affects everything. And what this is for is that on some GPUs, there is a problem when per texture scale is on, that you can get these single pixel dots that happen right between the blending of 2 terrain types. And it only happens when per texture UVs are on, and there's a very long and deeply technical explanation for why this happens. So I had originally fixed this and exposed an option like this a while back, but then I found what I thought was an actual fix for it. It fixes it on my GPU, it fixes on a lot of machines, but it doesn't quite fix it on every machine. So I reverted back a little bit to having some choice over the samplers. So to understand what these are is that when you sample a texture on a GPU, it's trying to be super efficient. And so what it does is rather than shade 1 pixel at a time, it actually shades 4 pixels at a time in a little square. And so when it's going across the screen, it's doing these in little tiny squares all the way across the screen. And the reason it does this is that it can fetch textures and share a bunch of data between these 4 pixels. It also has a lot to do with how bitmaps are calculated and things like that. But without getting too deep into it, just think about it as this way: as you know, the pixel shader works not on single pixels but rather on quads, and so by default, it's trying to work on these little quads, and it's trying to share a bunch of information between them so that it doesn't have to fetch as much information and can make the shader faster. So there are 2 overrides for this. The first is called LOD sampler, and this is what I had in the old version. What this does is, rather than having the low-level hardware compute the level of detail, the bitmap that it's going to use for a given pixel, I compute that in the shader. And for the most part, you'll notice I switched that and the scene doesn't really look any different. And that's because there's code around for how to compute that correctly. And so I compute that for the given pixel, and then I sample it. So now we turn on our per texture UV scales, which is what this is all about in the first place. When we start scaling things in really radically different amounts, they're all going to sample from the same MIP map. So if I set this to like 10, or actually let me set it the other way, let's go to like 0.1, then what you'll see is that this becomes really blurry. And that's because we're sampling the same MIP map that this texture is using, which is a much lower MIP than this one would actually need. So if I turn this back to default, then it'll be fine. But then occasionally on some GPUs, we will see these little lines appear between the textures. So there we go. So now it looks like it's supposed to. So why would you choose this mode? Why would you choose to use the LOD sampler? The reason you might do this is if your per texture scales are not that far apart, you're just scaling these things a small amount. If this is 1.4, then it all kind of looks fine. You can't really tell. And additionally, this is really, really fast. It actually makes the shader run faster than it does in the regular mode. And I have some theories about why this is, but I'm not entirely sure if they are correct. But it does run a fair clip faster than it does in the normal mode. And I think because it's basically having to do a lot less unique work. Now, the downside of this is that it breaks anisotropic texturing if you're using that, and trilinear filtering is not quite working as well because, again, I'm selecting the MIP map in the shader, and it's not letting the hardware do the work it wants to do to get those things a little more perfect. So you can run into some cases where things get a little bit blurrier because of this. But for most things, it's actually pretty fine, and it actually makes the overall shader run faster, which is a nice benefit, and it prevents any of these UV issues from these little tiny microscopic black dots from appearing. So you'll notice those maybe on lower res monitors and things like that. So that's one way to solve it. The other one is to use what's called the gradient sampler, and the gradient sampler is basically says, hey, you know how you were trying to share these 4 quads? Rather than do that, it actually forces each one to use to actually compute its own MIP level. So this also has the effect of clearing up those microscopic black lines, which again I cannot find on this GPU, but I've seen this fix it in other cases. But the downside is that this actually is a much slower rendering path, so it will slow the shader down versus, say, the default shader. But the upside is everything works correctly, so you get anisotropic and trilinear filtering. All of that stuff is computed correctly. It's just now computed for each pixel rather than every quad. So that does slow the shader down. Now, I've seen cases where using gradient sampling slows the shader down quite a lot when it breaks parallelism. And what's interesting is that, so this was actually something I did a lot of in MicroSplat and was actually able to get a much faster frame rate by not using the gradient sampler in that code. But for whatever reason, and again, it's hard to know exactly what the hardware is doing, but for whatever reason, it does not seem to cause the extreme performance difference I saw in MicroSplat in MicroSplat. And again, I have some theories about this, but they're a little hard to prove one way or another, even when you go in and look at the low-level driver information of what's happening. So because these things are a little bit hard to know, I've sort of exposed them. I don't like exposing these things. I'd really rather just take care of this all for the user. But this is a subtle and complex enough issue that it warranted exposing. And if you're not using per texture properties, then I would just use a default sampler. Unless you're optimizing for VR and you don't mind textures being a little bit blurry, then maybe use the LOD and you can get some more speed. So yeah, hopefully that's the end of that saga, unless I find a way to completely hide that control and not have to deal with that again. Okay, so that was far more technical than I normally get into. I hope it makes sense. I'm trying to see if there's anything else that I need to talk about in this. Yeah, I think that's about it. So this should hopefully be in the asset store in the next day or two. It is a version update, so it does require updating all of your modules because I had to change the API for sampling quite heavily. And so yeah, hope you're enjoying MicroSplat, and look forward to talking to you on the next one.